Introduction to Sets. So let's begin our exploration of sets. This is a foundational topic in mathematics, and understanding sets will be crucial as we move forward. Now the title of this slide is Introduction to Sets. So what is a set? The first point here states that in mathematics, a set is simply a well-defined collection of distinct objects, considered as an object in its own right. Let's break that down. Think of a set as a container; it holds things. But these things aren't just any random assortment, they need to be a well-defined collection. This means we need a clear rule or criteria for deciding what belongs in the set and what doesn't. And importantly, the set itself is treated as a single entity, a mathematical object. Next, it tells us that these objects within a set are called elements or members of the set. So, if we have a set of fruits, apples, bananas, and oranges would be the elements of that set. You'll hear both element and member used interchangeably, so it's good to be familiar with both terms. Now let's talk about well-defined. This is really important. It means that it's absolutely clear whether something does or does not belong to the set. There's no ambiguity. Let's look at the examples. The first one is the set of all primary colors. That's well-defined because we all generally agree on what the primary colors are: red, yellow, and blue. There's no debate. The next example is the set of all even numbers. Again, well-defined. We know what an even number is: any integer divisible by 2. Finally, we have the set of all students in your class. This is also well-defined at this moment. The members of this set are the students currently enrolled. However, if a new student joins or someone leaves, the set changes. So, to recap, a set is a collection. The things in the collection are the elements, and for it to be a proper mathematical set, it needs to be well-defined. In the next slide, we'll learn how to write these sets down using mathematical notation. Notation. So let's move on to how we write sets. As we discussed on the previous slide, a set is just a collection of things. Now, we need a way to clearly show what those things are. First, we use what are called curly braces. Think of them like little containers. We use an opening curly brace and a closing curly brace to enclose all the elements of our set. So that's and inside these braces, we list the elements, the individual objects that belong to the set, and we separate them with commas. It's just like making a list. Let's look at an example. We're going to define a set, and we'll call it A. This set A will contain the first 3 positive even numbers. Now, what are the first 3 positive even numbers? That's 2, 4, and 6. So, to write this set mathematically, we write A equals 2, 4, 6. We read that as A is the set containing 2, 4, and 6. Notice how the numbers are inside the curly braces and separated by commas. Now, to talk about whether something is in a set or not, mathematicians use special symbols. The first one is this. This symbol looks a bit like a lowercase e inside a circle. We say this as is an element of or belongs to. So if we wanted to say that 4 is in set A, we would write 4A. That reads as 4 is an element of a or 4 belongs to a. The opposite of that is this symbol. It's the same symbol but with a slash through it. We say this as is not an element of. Let's use that with our set A. The number 5 is not one of the first 3 positive even numbers, so we would write 5A. That reads as 5 is not an element of A. These symbols are really important for making precise statements about sets. We'll be using them a lot as we move forward, especially when we start looking at operations we can perform on sets, which we'll cover in the next few slides. So, make sure you're comfortable with what they mean. Types of sets. So let's move on to discussing different types of sets. As we've already learned, a set is just a collection of objects. Now, these collections can vary in size, and that leads us to categorize them. First, we have finite sets. A finite set is simply a set that contains a limited or countable number of elements. Think of it as a set where you could, in theory, list out every single item in it and eventually stop. For example, the set B, which contains the numbers 1, 2, 3, and 4, that's a finite set because there are only 4 elements. We can easily list them all. Next, we have infinite sets. Now, this is the opposite of a finite set. An infinite set contains an unlimited number of elements. You could never finish listing all the elements, no matter how long you tried. A classic example is the set of all natural numbers. Natural numbers are the positive whole numbers, 1, 2, 3, and so on, continuing forever. We represent the set of natural numbers with a special symbol, a capital N with a double bar, which we read as N double bar, and then we list the elements as 1, 2, 3, with an ellipsis, those 3 dots, to indicate that the pattern continues infinitely. Finally, we have the empty set. This is a bit of a special case. The empty set is a set that contains no elements at all. It's like an empty container. It's denoted by a special symbol, a slashed circle, often called the null set, or simply by empty curly braces. Both of these notations mean the same thing, a set with absolutely nothing inside. Understanding these different types of sets, finite, infinite, and empty, is crucial as we move forward. In the next slides, we'll explore how to represent these sets in different ways, like listing out the elements or using a more concise notation. So, make sure you have a good grasp of these definitions before we proceed. Representing sets. So now we're moving on to how we actually write out these sets. As we've discussed, a set is just a collection of things, and there are a couple of common ways to represent them. First, we have the listing method, also known as the roster method. This is exactly what it sounds like. You simply list all the elements of the set inside curly braces, separating each element with a comma. This method works really well when you have a finite set, meaning a set with a limited number of elements. Look at the example. C equals the set containing a B, C, and D. Notice how each element is inside the curly braces and separated by commas. So, C is a set containing those 4 specific letters. Now, what if we want to define a set that goes on forever, like all the even numbers? Listing them all out would be impossible. That's where the second method comes in, set builder notation. Instead of listing everything, we describe the elements of the set using a rule or condition. Let's look at the example. We're defining a set D to contain all even numbers. We write it as D equals the set of all x such that x is an even integer. Let me break that down. The x represents any element in the set. The vertical bar, we read that as such that, separates the element x from the condition it must satisfy. So, x such that x is an even integer means that any number x that is an even integer will be included in set D. This is a very powerful way to define sets, especially infinite ones, because it tells you how to create the elements of the set, rather than listing them all individually. We'll be building on these ideas in the next slides, so make sure you understand these 2 methods of representing sets. They're fundamental to working with sets in mathematics. Key takeaways. Let's recap everything we've learned about sets with these key takeaways. First, remember that a set is fundamentally a collection of distinct objects. By distinct, I mean each object appears only once, no repetitions allowed. Think of it like a unique group of items. Next, we use specific symbols to work with sets. We denote, or write, a set using curly braces. That's the symbols that look like this: open brace, close brace. Everything inside those braces represents the elements of the set. Now let's talk about how we indicate if something belongs to a set. We use the symbol is an element of, which looks like this: a sideways E within a larger in symbol. We would say is an element of or belongs to. For example, if we have a set A and the number 2 is inside it, we'd write that 2 is an element of A. Conversely, if something is not in the set, we use a similar symbol, but with a slash through it, it's the is not an element of symbol. Moving on, sets aren't all the same size. They can be finite, meaning they have a limited, countable number of elements, like the set of vowels. Or they can be infinite, meaning they go on forever, like the set of all whole numbers. And finally, a set can even be empty, meaning it contains absolutely nothing. We represent an empty set with a special symbol, a large, slanted 0. Finally, remember that we have 2 main ways to represent sets. We can list all the elements inside the curly braces. This is called the listing method or roster method. Or, especially when dealing with infinite sets, we can use something called set builder notation, where we describe the elements using a rule or condition. We covered that in detail on the previous slide, so feel free to review if you need a refresher. These are the core concepts of sets. Understanding these will be crucial as we move forward and start performing operations with sets in the next few slides. So, make sure you're comfortable with these ideas before we proceed. Common mistakes. First, it's crucial to avoid confusing elements with sets. Think of it this way. A set is like a container, and the elements are the things inside the container. So, if we have a set of fruits, the set itself is the collection, and the apples, bananas, and oranges are the elements. The set is the collection, not one of the items within it. Next, remember that sets only contain distinct elements. This means no repetitions. If you write a set like this, 1, 2, 2, 3, it's actually the same as simply writing 1, 2, 3. We only list each unique element once. The repetition doesn't change the set itself. It's like saying you have a group of friends. Listing a friend's name twice doesn't mean you have more friends, just that you mention their name again. Finally, let's talk about notation. We've already covered the symbols for is an element of and is not an element of. Remember, the symbol that looks like a rounded E, we say is an element of or belongs to. So if we write 4 is an element of set A, it means 4 is one of the objects contained within set A. Conversely, the symbol that looks like a rounded E with a line through it, we say is not an element of. So, 5 is not an element of set A means 5 is not in that set. Be very careful to use these correctly, as they are fundamental to expressing set relationships. Let's move on to the final slide, common mistakes students often make when working with sets. Understanding these pitfalls will really help solidify your understanding. These are the most common errors I see, so paying attention to them now will save you frustration later. Now that we've covered all the basics of sets, you should have a solid foundation for more advanced topics. Do you have any questions about any of these common mistakes, or would you like me to go over any of the concepts again?